Good morning, Algebra 2. Let's get started on Unit 3 notes, Day 3. Now, there's some steps here. Step 1, Step 2, Step 3, Step 4. If you want to read through that in your own time, go ahead. I just explain all this stuff as I actually work the problems. Okay. Here's what you want to do. If we're going to solve this example algebraically, we need to figure out if we were to combine, let's say, hang on. Let's say I got rid of this row right here. Let's just pretend it was these two rows. Wouldn't we be able to use elimination and get rid of the z's? Well, let's do that. So I'm going to combine like terms vertically, 2x and 3x. Notice they're both positive. If you combine them, you get 5x. Now the y's, negative y and positive 2y. If you combine them, you're just going to get y. Now the z's are gone, remember. And now positive 1, positive 3, if you combine positive 1 and positive 3, you get positive 4. Now, let's pretend like the top system doesn't exist. If we did the exact same thing, except now with this row and this row, let's see what we get. Combine positive 3x and positive 4x. Now combine positive 2y and negative y. If you combine the z's, they are gone. And now if you combine positive 3 and positive 3, that is positive 6. So that's what you want to do first when you are given 3 systems of equations with 3 variables. You got to figure out in which manner can we eliminate at least one of the letters. Now that we've done that, let's eliminate another one. Looking at the x's and looking at the y's, it looks like it'd be easier to eliminate the y's if only one of them was negative. So how about we multiply this top system by negative 1? We're going to multiply everything by negative 1, and I'll write that result out here to the right. So if you multiplied everything up here by negative 1, that's your result. And let's just carry over this bottom system here. Now, if you combine your x's, negative 5x, positive 7x, combine them, that's 2x. Your y's, gone. Negative 4y combined with positive 6, that's 2. And now we can solve for x. Divide both sides by 2. X equals 1. Now that we know what x is, I'm going to use this system here, and I'm going to substitute 1 for x. So instead of 7 times x, we know what x is. It's 1. Well, 7 times 1 is 7. And now subtract both sides by 7. And now we know what y is. Y is negative 1. Now we have just enough information to figure out what is z. So we can pick either one of these original systems and substitute what we know to solve for what we don't know. I'm going to pick the middle one. So instead of 3 times x, let's do 3 times 1 because that's what x is. Plus, instead of 2 times y, let's do 2 times negative 1. Plus z equals 3. Now let's solve. 3 times 1 is 3. 2 times -1 is -2. On the left side of our equation, we can combine these like terms. 3 minus 2 is 1. Subtract that 1. Z equals 2. And now we have solved for x. Now we have solved for y. Now we have solved for z. Let's move on to example 2, which I have written down on my paper already. Hopefully you've realized after solving example 1, there's a lot of moving parts whenever you're dealing with 3 systems of equations that involve 3 different variables. Today's lesson is to not only show you just how amazing I am at doing math because I was able to do that problem. No, it's more to show you how do we do that using a graphing calculator? Great question. Well, the first thing you're going to want to do is you're going to want to turn it on. Now, there's a lot of steps involved to using your graphing calculator to solve these systems. Practice, 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 and the steps will eventually get ingrained into your memory. Here's what you want to do. Push second, and then matrix. It's that X to the negative first power button. You're going to see this screen here. You want to scroll all the way to the right, and you want to push enter. Now, odds are, hang on just a second. Okay, I wanted to start with the fresh screen because odds are your screen didn't look like mine. This is most likely what your screen is going to look like. So let's start that process over again. Second, and then that button right there, matrix. Scroll all the way to the right and push enter. Now we have to tell it what type of matrix we're dealing with. Matrices consists of rows and columns. We have 1, 2, 3 rows and 1, 2, 3, 4 columns. Therefore, this is a 3 by 4 matrix. So let's tell our calculator that. 3, enter, 4, enter. Now, from this point on, it's pretty straightforward. You're going to then enter all the coefficients. And after you enter the coefficient, press enter. So starting here, you're going to do 4, enter. -3, enter. 5, enter. -19, enter. And then now we're at this row. 3, enter. -1, enter. -8. -21. -2. 1. 3. And 13. Once you have done that, push second, quit. Now we got to go back to the matrix. Second, matrix. Push your right arrow key once. And now hit the up arrow key 5 times. You should be on B, R, R, E, F. Now hit enter. Now let's hit second, matrix again, and push enter once, enter twice. Now here's what your answers are. Your answers are to this very right column. X is -3, Y is +4, and Z is +1. Once again, that very far right column, that's your answer. But listen, notice the pattern that we have here. That is very important. We need it to look just like this. We need ones going diagonally this direction and nothing else but zeros in the other spots. If you don't have that, your calculator's trying to tell you something. But we do. So this is our answer. Let's now move on to the other examples. Now you try, Alvin, with your inverse matrix on calculator. I really like this example because not all of your problems are going to be set up perfectly like our previous two examples. You want to follow the example of this very top system. They give you an X value, then a Y, then a Z, and that is equal to a constant. It must follow that pattern, X, Y, then Z. If it doesn't follow that pattern, then you have to rearrange accordingly so that it does follow that pattern. Now look at system 2 here. They give us an X, they give us a Y, but there is no Z. So in its place, put 0Z. The third system, that one's fine. Okay, and now we can use our matrix calculator. Let's do it again. Second matrix, all the way to the right, push enter. Now all these that we're doing today are 3x4s, so 3 enter, 4 enter. And now don't worry about deleting anything, just start plugging in your new data, and as you do that, it will eliminate the old data. So 1 enter, -2 enter, 2 enter, 9 enter, and so on. Once you've entered all your values, second, quit. Now back to the matrix. Second, matrix. Push your right arrow key once, up arrow key 5 times. BRREF, that's what we want. So push enter. Back to the matrix. Second, matrix. Now push enter twice. Once, twice. X equals 1. Y equals -1. Z equals 3. And then look at the pattern. Notice the pattern. Ones diagonally and nothing else but zeros in those other columns. That's what you want. Now, at this point in time, you might be thinking, this is a lot of steps. I don't want to memorize this. Well, fine. Then do it algebraically. But you're going to need to choose your difficulty. They're both difficult. Either learning how to do it algebraically or learning how to do it using your graphing calculator. Choose which one you'd rather do. Okay, example 4, special cases. I'm trying to give you a hint here. Let's see, is everything set up perfectly for example 4? X, Y, Z, constant, X, Y, Z, constant, X, Y, Z, constant. Yes, it is. Let's go, matrix calculator. Second, matrix. Scroll all the way to the right and push enter. 3, enter, 4, enter. Now start entering all of your coefficients. Once you've entered everything in, second, quit. Now back to the matrix. Second matrix. Right arrow key 1 time, up arrow key 5 times. Push enter. Back to the matrix, second matrix. Push enter twice. Oh my goodness. Now you might be thinking, well, X is 0, Y is 0, and Z is 1. X is 0, Y is 0, and Z is -1. But look at the pattern. I don't see ones going diagonally perfectly. I don't see nothing but zeros in all those other spaces. Your calculator's trying to tell you something. We're either dealing with infinitely many solutions or no solution, and this is the easiest way to determine which one it is. You can pick either system you want. Let's pick this one. I want to pick the top one. And let's substitute the answers that it gave us. It said x was 0. It said y was 0. And it said z was -1. Oops, I realized I'm using the wrong one. Sorry. There, that's the one we're using. It said x was 0. Y was 0. And z was -1. Okay, well, 2 times 0 is 0. 4 times 0, 0. 10 times -1 is -10. And we set that equal to 14. Now you're just determining, is this a true or false statement? Well, it's false. -10 does not equal 14. Therefore, your answer is no solution. And now example 5, looks like we have our x's, we have our y's, we have our z's, all perfectly aligned, and all of our constants. So let's use our matrix calculator here. Second matrix, scroll all the way to the right, and push enter. As I mentioned, these are all 3 by 4, so 3, enter, 4, enter. Now start entering your coefficients. Once you've entered them all in, second quit. Now back to the matrix. Second matrix. Right arrow key once. Up arrow key 5 times. Push enter. Back to the matrix. Push enter twice. Ooh, notice the pattern. No, we don't see ones diagonally, and there's a 2 there where the 0 should be. Let's write down what it tells us x is, though. Let's write down what it says y is, and let's write down what it says z is. Okay, we can pick any system we want. Why not just go with the top? And let's substitute. 2 times 3 minus 2 times 0 plus 4 times 0 equals 6. Well, 2 times 3 is 6. -2 times 0, 4 times 0 equals 6. Now we have to determine, is that true or is that false? Well, it's true. 6 equals 6. So your answer is all real numbers, infinitely many solutions. I just don't want to spell that out. That's your answer, infinitely many. And now example 6. I'm going to work this one silently to give you an opportunity to practice this on your own.